Everyone, my name is Praveen and I have Sridhar Ishwaran with me. Today we are going to present our Kaggle Notebook on Wikipedia GenAI quiz generator. So this tool um, is a project that turns any Wikipedia topic into an instant study quiz. Some of the challenges that people face when they want to learn a new topic is that there's so much of information and people um, tend to drown in the overload of information. And many of the times, even when you get a chance to go through all that information, how do you make sure that you have retained at least a good chunk of the information that you try to learn? Um, Having a way to check your knowledge using a quiz is a great way. However, creating a manual quiz is often slow and subjective, and there is no way to make sure that um, it is accurate and it is scalable when you have a lot of content to go through. So here we try to propose a solution that makes this job really easy. At a high level, here's the idea. When someone wants to learn on a topic, it prompts the application. The application uses a set of large language models and a vector database to to fetch and store the content. It generates a summary of the topic that the user wants to learn, and it also uses LLM evaluation techniques to make sure that the questions and answers that it would generate at the end of the processing are grounded on the material that is gathered, and then it presents the output in a structured JSON format. So here's on the right side, you would see um, the end-to-end workflow, and I'm going to switch into the code. Um, so to start with, we initialize a couple of models. We have a cold LLM, which has a temperature of 0, and a hot LLM, which has a higher temperature and top K and top P values to ensure more creative response. So we use these two different models, one for generation of the questions where we want to have more diverse and creative questions asked. At the same time, we want to ground the responses to the material that we collected. So we use a cold LLM to evaluate the responses generated by the quiz generation component. Okay, the first step here is um, to make sure that we are able to extract a Wikipedia searchable topic from the prompt. And to help with that, we define a set of pyramidal schema classes. And we use the Wikipedia API wrapper from LangChain. And then we have um, a prompt define whose job is to take in a from the user or topic or any conversational aspect that indicates that the user wants to learn some information, and it evaluates the prompt using an LLM and then tries to extract a topic from the prompt and presents an output in a JSON format in a structure like this, wherein if the model is not able to identify a searchable topic, it returns back to the calling component with a false, and it also adds a message that could be shared with the user to probably change the prompt. So let's take a look at some of the examples. So here, um, this is the input we get from the user. That's why did the chicken cross the road? And let's see if the model is able to evaluate topic from that. As you can see, it said the message, it requested the user to rephrase the message to focus on a specific um, encyclopedic topic. So it returned a false. And now let's see how would the response be if we have something more um, that you can search on Wikipedia. So this time it gave a response of true, and then it extracted space exploration as the topic. So that's the first prompt validation and topic extraction component. Next, we do a simple Wikipedia search using the topic that we extracted. This part is pretty straightforward, and we get a blob of text that looks something like here. Um, and the next step is to split them into smaller chunks and store it in a vector database. We have used the phrase vector store, which is a very powerful um, vector store from Facebook. Um, and the chunk and embedding method does the job of splitting it down into smaller chunks. So here we set a chunk size of 2000 and providing an overlap of 200 using the cursive character text splitter. So this way, if sentences get broken halfway through, you have an overlap of 200 so that the context is not entirely missed. And we create a store and then store the embeddings, generate the embeddings and store it in the vector store. And then when you run the chunk and embedding, it also returns JSON response indicating if the operation was successful and how many chunks were created and so on and so forth. Next is the summarization. So here we have spent some good amount of time to make sure we get a very concise yet a relevant summary. We use the LangChain's MapReduce summarize module. So it has two components. It has a map prompt and a reduce prompt. Then we split it down into smaller chunks and then build up the summary by combining the chunks together one by one. The next step is having a mechanism to validate the quiz. And this is also one component that we have spent quite some time developing. So the validate quiz component takes a topic and a question, a schema. So this is a pydantic model that has a question and answer and 3 distractors. So the basic idea of the validate quiz is it makes sure that the uh, the question and answers are relevant to the topic. Um, and as I said before, it uses a cold LLM with a temperature 0 to make sure that the results that we have are not too far away and it doesn't try to hallucinate much. And the responses that we get are as much as possible from the content that we have retrieved. So the first check we do is if the question is relevant to the topic. So we use a prompt for that and then create a LangChain QA chain and then run it. And if the response we get, if there is a no anywhere in the response, then we assume that this is not the valid question answer pair, and then we return a false. We do the same thing to check if the answer is the correct one for the question. We also do another check to check if the answer is relevant to the topic. And finally, if everything checks out, we return back a true. So that is a validate mechanism using Gen AI evaluation. And that evaluates a single question against a topic and the information we have chunked up and vectorized and stored in the vector store. And then is the final component, which is generating the quiz itself. So here we have provided a few short prompt to ensure that we have a diverse set of questions, and we try to base our questions and answers on different things like people, places, dates, um, and so on and so forth. And we have given a couple of examples for two different topics. And we try to generate a question at a time, and we run it through some checks. Like we want to make sure that no questions are repeated, and also yeah, answers of different questions are not repeated. So it is just to avoid that you don't ask the same question in a different way, so that you end up with the same answer. Um, and then we also check if the question is valid. We're calling the validate quiz question. And if everything checked out, then we add the question to the generated list of questions. Here we have, because we start off with the target of generating a certain number of questions. So in this case, the default is 5. So we keep trying to generate questions until we hit that number. And we also have a max retries option. So for some reason, if the model is not able to create the correct number of questions within a certain number of attempts, then we don't want to end up in an infinite loop. So if that happens, the component will exit and come back after about 50 retries. By default, you can also configure that. So here's how it would proceed if you call this method with this topic. You can see that it generated 3 questions. And if you pay attention to the question, all of these questions are different, um, and also relevant to the topic that we picked up. And finally, we have the pipeline component, which would combine everything together so that um, a consuming component just have to call the run pipeline and pass a topic, and then pass the number of quiz questions you want to generate. I'm setting a low number because I don't want to exceed the AVI call limits. So as you can see, it logs all the output here. You have a Wikipedia search. It identified space exploration as so the space exploration was the topic, and then it found some pages for that topic, and it generated a summary. And as you can see, it also generated um, the desired number of questions. So that's at a high level of what our solution is. Coming to the impact, we think that this is going to have a great impact for educators who can build practice sets pretty much instantly. The learners also can um, have their time very effectively used to learn something really quickly. And this application, as it is now, is API ready because the output is JSON. It can be directly consumed by chatbots, LLMs, mobile apps, etc. So that's all. Thank you very much, everyone.